You hear me well. Yeah, good afternoon and welcome to this meeting on green and resilient construction, how to achieve 30 to 40% reductions now. My name is Christian Egenhofer. I'm working here at CEPS and the European University Institute, and I'm moderating this session. The title suggests that there is a lot of opportunities to reduce now. Of course, it's understood that in order to get to net zero 2050, there is much more to be done, much more is required, and especially also how to combine the short term 2030, low-hanging fruit with the real deep reduction in the longer term. That's often forgotten. Yes, you can do a few things now, but then you live with a building stock that is substandard, and what do you do with it, and how do you use it, recycle, etc., etc. We will come to this. The meeting is a joint meeting between the WIFO, which stands for the Austrian Institute for Economic Research, and CEPS, and it's part of the Reconstruct project. Reconstruct is a forum which is operating, a small forum, I should say, a small forum, which is operating in Vienna and Brussels, where we reflect and discuss the sustainable construction with stakeholders, all multi-stakeholder groups, stakeholders from industry, policy, the civil society, and of course, research. Essentially, we are doing conceptual work, and the more empirical, technical work is done by people like Marcella from the Technical University of Graz, who is very much involved in all kind of construction materials work and so on. She will tell us later. Finally, as to the proceedings, we'll start with a short introduction by Stefan Schleicher, who will present in a few words the Reconstruct project. Then we are having Peter Flotzinger, who is sitting here. He's the CEO of a small and medium-sized construction company, and he will talk about how they handle this and the opportunities and the challenges they are facing. Then we're coming to Marcella Sade, if I pronounce your name correct. Okay. She is the Deputy Director at the Technical University of Graz, and she will present a few case studies on what's happening before Sebastian Spaun from the cement industry will talk about thermal component activation. If you don't know what it is, Sebastian will explain it to you, and then Zoltan Todd, who is team leader in the Buildings Performance Institute Europe, sort of part of the Brussels bubble, if I may say so, will give a low carbon roadmap, and then we can compare notes and go in a panel discussion where we discuss what is needed for the panel, what is needed from a policy framework. The meeting will be recorded, not live streamed, but it will be recorded, and you can go back to YouTube, the CEPS YouTube channel, where you will find the proceedings there. I hope the meeting is as interactive as possible. It's very interactive, so please, if any of you have a question, comment, raise your hand, speak up. There are microphones so that we really get into the discussion and avoid or restrain from making statements which are a bit more conventional. So, let's really get into challenge each other. It's a big group, but I think it's still feasible. I think with this, I stop here and give the floor to Stefan Schleicher, also from WIFO and the Wegener Center and many other functions, and he's the real person, one of the real persons behind Reconstruct. Stefan. The clicker is here.
Okay. So, just need to get organized. Yeah, good afternoon from my side. In a nutshell, what is reconstruct? Um, a good motivation for what we are doing comes from Peter Richner. You know, he's deputy director of EMPA in Switzerland. That's I would say, a very top-rated research institution in Switzerland, and we cooperate with them quite a bit. And he said last September at a meeting of Swissbau, we spend 80% of our time in buildings or on the way between buildings because mobility is more or less, I would say, a consequence how we structure our build stock. And you know, with this perspective, we get, I would say, a very new understanding about the amount of energy and emissions which are related to the build stock. And I think this is something like a mantra of the Reconstruct platform. And you know, just in a nutshell, how did we start and how are we proceeding? Of course, we started out with issues related to low carbon construction materials. And you know, this is still something we are very much interested in. And I want to mention that Austria is really leading already in low carbon cement. At least I would say if you compare Austria with all the other member states in the European Union. But pretty soon, what's going on? Pretty soon we realized that we need to look at the full value chain in the use of building materials. And we definitely switched to what we call a systemic approach to the use of materials in general and construction materials in particular. And to give an example, for example, this is the design of a staircase, which was very much inspired by the structure of a spine. And we'll definitely hear more about, you know, these design principles quite in a few minutes later. Something is, wait a minute. Okay. And I think the third step was that we discovered that buildings can have a very active functionality, as we want to call it, in localized energy systems. And this is also something which will be presented in more details later, where we are discovering that buildings have an outstanding capability of serving and providing thermal services. And well, so that's a kind of a, okay, now I made it. And the next step was that we recovered that we really should look at what we call ensembles of buildings, not just a single buildings, but how buildings interact and could interact. And we really learned a lot about this in Switzerland. In Switzerland, there are now some outstanding new developments which are called Quartiere, you know, urban development projects. For example, this one is the so-called Papiri Quartier. This was a paper factory which was operated for more than 300 years. And this is being converted now to a very innovative urban development project. And related, to this innovative architecture, what we call integrated functionalities for living, for working, and other activities, these projects are outstanding in their energy concepts. And the key word are so-called energy hubs, because they demonstrate that on a very localized scope, you can provide all thermal energy services for heating and cooling locally. And this is done mainly by the so-called energy grid. Energy grids is also something which needs to be given much more attention. These are low temperature thermal grids connected to local geothermal components. And about 60 to 80% of electricity. And in my opinion, this is really something which should be given much more attention in our discussions, how we should restructure, in particular, the electricity system. And I would say this is now, our latest achievement, because we have discovered that the construction industry could become a focal point for what we call circular carbon management. And I think the Reconstruct community has at least some responsibility for coining this term. So circular carbon management is something we are really very much proud of. And this is what we like to call the Austrian flagship project, for this concept. And basically what you see, and you will get the slides later, this describes how CO2 emissions from a big Austrian cement factory, about 700,000 tons per year, could be captured, combined with hydrogen, which is also produced locally. And the CO2 plus the hydrogen could be converted into what we call synfuels and oleofines, synthetic oleofines. And the synthetic oleofines, would end up for producing very advanced polymers. And at the end of the lifetime of the polymers, the polymers could be returned or recycled in the cement company. And this would close the carbon cycle. And I really could tell a lot about this project, because it has so many, I would say, outstanding features, and it's getting really international attention. But this is my story, and I'm really looking forward to our joint discussions.
Yeah. Thank you. I just literally hand over the microphone to the next speaker.
Perfect, thank you. Welcome from my side as well. Thank you for the possibility to present the approach from the point of view of an SME. My name is Peter Flotzing. I'm CEO of the company Senftenbacher, a small and medium enterprise based in Austria, producing heavy clay bricks. I want to start with a few pictures where we can see how we can shape our future. Even as an SME, we have to describe how we want to see our future, how we can tackle the challenges that we are facing, and we can decide what we do. As an SME, we have limited possibilities, and therefore we have to make cooperations with different other organizations, different other companies, in order to achieve what we are willing to do to reduce the carbon footprints of our buildings. And we have two different approaches. We are facing on the sustainable product use, not only the construction of the building, but also the operation of the building. And of course, the sustainable production itself, where we can make actions in our own company. And I think this is a basic need that all companies in European Union have to tackle. For the first thing, the sustainable product use, we developed together with scientific assistance a model, the so-called the Brick Bauhaus 2050, that describes a building standard, how we want to describe a building with a carbon footprint as high to reach the 1.5-degree goal based on the European Green Deal. On the slide you can see the Brick Bauhaus Sun with where there are shown the 9 qualities we described, where we want to show what's the impact, which qualities have impact on a footprint of a building. I want to pick out a few. We have 3 main perspectives. First of all, the ecology. Of course, the first point, climate neutrality, very important, but not only the most important one. Second thing is the economic perspective of a building. A building should be affordable too. It's not only that it's climate neutral, but also affordable, for example, and therefore the circular economy, the regionality is very important too. And third, the social quality is very important too. It's not only economy and ecology, it's also the social quality. You can focus on the UN SDGs or the comfort that a building offers. And it's a mixture of all these 9 qualities in order to reach a sustainable building. A goal without a plan is just a wish, and therefore we set a target based on scientific knowledge in order to reach the 1.5-degree goal. And it's described as 11 kilograms of CO2 per gross floor area and year, describing for one building. And it's separated in construction and operation. And you can see this is an example of a real building in Austria. It's not only construction, it's operating, and the possibility for savings, for reducing the footprint. We have different possibilities to reduce the footprint, and we have used them in order to reduce the footprint, the carbon footprint of a building. As I told, I want to pick out a few things that we as an SME can tackle on ourselves. For example, the circular economy, cradle-to-cradle approach. We think it's the only way to make a fair comparison, balancing CO2 emissions for a product and the life cycle, the durance of a product, for example, as a brick, 150 years and more, has to be taken into account in order to make a fair comparison. Circular economy, we live circularity. Mineral construction materials are infinitely recyclable. We have to shift from, you can say that mineral resources are used and not consumed because they have a second, a third, a fourth life and so on. Maybe as a different product, maybe as the same product. We have different possibilities and we have to use them. The urban mining is very important. We have to see which possibilities there are, and also we have to take into consideration the biodiversity, which is a basic need for and a good possibility for our industry where we can make an impact. Regionality, I said too. We are known for regionality. Our products stay within a very short distance from our factories. This is also a thing we can have influence on. You can see the figures. We are not talking about thousands of kilometers. We are talking about less than 100 kilometers where our raw materials come from and where the products go to. I think this is a very important thing to talk about. Yes, then a step on to the green production. Of course, it's not only the product use. Here we have different possibilities to reduce our own carbon footprint when producing our bricks. Here you can see, for example, in the middle is a photo from our factory. We are investing in new technology in order to reduce our footprint. There are different other possibilities and ways to do so. Green hydrogen, shifting to electricity, driven kilns. We have different possibilities, but as an SME, we need support from government, from public side, in order to tackle these challenges. Our needs, yes, we have to invest a lot of money in order to tackle this challenge. We have already accepted the challenge, that's absolutely clear. And we are, I want to live myself in a good future and in a low emission future. And therefore we need a good supply of green energy. But we, as an SME, can't become full energy suppliers. That's not possible. We're investing in PV, but we can't produce our own energy for the whole company. Therefore, we need public support. And also, in order to tackle the process emissions, there is a topic too, CCU, CCS. We have to tackle this topic too in order to reduce our process emissions. Yes, we are happy that the European Union has seen these challenges and is working on these challenges with different programs. For SMEs, I don't want to talk on every topic here, but simplification of procedures is very important for us. We don't have the staff to invest a lot of time and money in the procedures themselves, but we need simplification, then we are ready to do so. For further information concerning the Brick Bauhaus, you can visit this website. There are more details. And from this side, thank you for your attention.
Yeah, thank you, Peter. I think we'll take the questions a bit later. You know, please write them up. There will be plenty of opportunity. We are going now to the next speaker, Marcella Sade, who will present a few case studies from what you're working on. Thank you.
Thank you. Good afternoon, everyone. So what I intend to quickly show you today, I'll try to keep it under 7 minutes, is this material and GHG savings potential of a demand-side mitigation strategy, using lightweight concrete structure as an example. But what do I mean by demand-side GHG mitigation strategy? So the IPCC publishes these scenarios that we all know, right, on temperature increase and some mitigation pathways on how we limit global warming. These scenarios are based on so-called integrated assessment models, and these models rely heavily on supply-side mitigation strategies. Demand-side options, which are mostly related to a decrease in consumption in general, are often excluded from these models. But we all know that ambitious demand-side mitigation strategies have the potential to really reduce the need for negative emission technologies, which are typically associated to a higher risk and a higher cost. Now, the importance of this type of strategy in the built environment is made even more evident when we consider that the increase in energy efficiency of buildings led to what we really needed, a decrease in whole life cycle GHG emissions, right? But it also led to an increase in embodied emissions, as you see here in this graph. So embodied emissions now are becoming fast the dominant portion of the life cycle GHG emissions of a building, right? And the thing is, we're risking a carbon lock-in effect. The choices that we make today in terms of materials and amounts of materials that we use is something we won't be able to change later on. So we believe that reducing the material demand is the natural and effective first step, analogously to what we did to reduce operational GHG emissions. We first reduced the energy demand of buildings, right? So let me quickly show you how to do so with building, with concrete structures, lightweight concrete structures. So this project that I'll share with you called Coebro from the institute where I work, the Institute of Structural Design at TU Graz, it sort of is based on this idea that is inspired by what happened in the past when material costs were really high, that we could have light, slimmer concrete structures with far less material performing in the same way. And we do so through additive fabrication or 3D printing in this project. So what you see here, there are some careful structural calculations that are done to ensure that we can find the geometry that keeps the structural stability of the structure while allowing for some significant rate reduction through this, what we call displacement bodies. So it leads to these voids that you see here in the picture. So like I said, we have to do some very careful structural calculations and determine the best possible geometry that will allow for maximum weight reduction. In this project, this is a prototype. This figure that you see here is a prototype of a flat slab for a roof. And there was a 40% reduction in concrete weight in this slab. And they actually constructed a section of the slab that you see highlighted here to perform all the testings to make sure the structural stability was there. And what the tests showed after it was built, or sorry, perhaps let me allow you to show you the step-by-step of this thing. So we define, let's say, the shape, the optimal shape of these displacement bodies. Then it is printed with a robot that is now at TU Graz, at the Laboratory of Structural Engineering. Once they were printed, they were brought to one of the research partners' facilities, and they were positioned like so, according to the plans, according to the geometry that was set. Once they were carefully positioned, there's reinforcement that is put in, and then concrete is conventionally poured, right? So where do I want to get with this? The preliminary life cycle assessments that were made in that section of the flat slab that I just showed you, they actually indicated, apart from meeting all the structural requirements, that there was a reduction in a quarter of the GHG emissions, 25%. But if we had also changed the mix of the concrete that was poured, typically, we could get up to almost 40% GHG emission reduction in comparison to the original design. Now, after this prototypical testing, the team was also able to test this concept in real-world cases. This is a project in Nördlingen in Germany, actually won a very recent winner of the prize on concrete architecture. And the team was commissioned along with some research partners to build this ceiling for an underground parking lot. So a very similar process to what I've just shown you happened. First, there were the calculations to determine the optimum geometry and the optimum shape of these displacement bodies, as we call them. And then once they were printed, in this case, we had to define the best printing strategy to ensure stability. Once they were printing, there was the definition of what was the, let's say, most efficient way to transport them to site, because they have to be safely transported, so it's an added challenge of this strategy. And then they're positioned according to the geometry that was set before. Steel reinforcement is put in place and concrete is poured, typically, as before. In this case, there was a reduction of 35% of the GHG emissions in comparison to the original design. And there was the use of a concrete mix that was optimized in terms of CO2 emissions. Now, the last example that I'll show you is this one. It is the largest of its kind constructed today. It's in Vorarlberg in Austria. And this is actually a flat roof with over 700 square meters of area. So there were 792 of these boxes or displacement bodies that were printed. And it led to a very significant reduction as in the first case. Of course, there were a bit more challenges because it was just the sheer amount of displacement bodies that had to be transported. But it was all done successfully, and it was built recently in March this year, as you can see here in this picture. Very similar to the first project I've shown you, or the first prototype I've shown you. Again, here we got a 25% reduction in impact, but using an optimized CO2 reduction, one can get up to 40% reduction in GHG emissions. But what now? How do we implement this in a wide scale, ensuring maximum GHG emission reduction without trade-offs, environmental trade-offs, due to the additional activities that are needed for this concept? So our next research goal is to design careful prospective life cycle assessments where we can explore different material compositions, different printing strategies, adaptation of construction sites, and try to predict the evolution of this technology as it reaches higher readiness levels. And that is done through careful scenario modeling. So there's a more robust statistical assessment in this LCA to make sure we can predict it. The idea is to have the pathways that would point us to the best outcome, both in terms of reduction of GHG emissions, also in terms of cost and minimum trade-off, to explore the maximum potential of this demand-side GHG mitigation strategy. But to sum, my message is we strongly believe that this efficiency-first paradigm that was so successfully applied to reduce operational GHG emissions should be replicated in the embodied emissions realm, because it is typically a lower cost option with lower risk of environmental trade-offs, and it leads to our so desperately needed reduction in environmental impact. Thank you.
Thank you. Okay. Thank you, Marcella. Also, not just for outlining the technology, but also for showing an implementation path. So we will, Katharina and the other panelists, we will go back to this. So the next speaker is then Sebastian. And I give you the microphone and the clicker.
Thank you, Christian. Since it's recorded, I need a little bit of piece of paper. My English isn't that good. Let's start. Yeah, you will realize Austria has a lot of practical examples. So will I go on. The silent power of mass in a building is the topic of my presentation. Heat waves are getting more, and heat waves are getting more intense. This is a picture of Austria in the second half of this century. If we react in that way to go against the heating up of our cities, it would be the completely wrong way. This is my first aspect. Second, heating and cooling of buildings is responsible for close to 30% of the global CO2 emissions. Another 11% are the materials Marcella was speaking about. And then, of course, a big part of the transport can also be allocated to what we all do here. So building is in the center of our decarbonization strategy. So we definitely have to act. So what can concrete core activation do? What we need to do is we need to heat and cool our houses with renewable energy. Of course, first we have to isolate the houses and bring down efficiency first, bring down the demand. But renewable energy is fluctuating. Sun and wind is fluctuating, and therefore we need storage facilities. And what I want to speak is how can we use the concrete that is anywhere there in the housing, the ceilings, especially the ceilings, how can we use the ceilings to store the energy of wind and sun energy? First project I want to speak looks very simple, but it was a milestone project. With this house, we tried to heat this house via a heat pump, and the electricity for the heat pump was coming from a wind park 100 kilometers away from this house. And it was our goal to show that when we store the energy via the heat pump, when the wind is in the grid, then we can store it in the ceiling. And when the wind is gone, the heat comes out of the ceiling by itself. Here you see a typical wind profile of a wind park in Austria, very typical. You see the west wind, the same as in Belgium, is going through Europe and comes one day, it stays one day, and it goes one day, and then probably we have 2 or 3 days a break without wind, probably without sun. So what we can show with this simple house was, I jump back. Here's the technology. It's the most primitive technology you can use. Instead of putting the pipes in the floor, we put the pipes in the ceiling because the ceiling is like 20 centimeters, or we could use Marcella's ceiling. It would work too. So what the only thing you need is 5 meters of plastic pipe per square meter. It costs you €4 per square meter, probably. In the second year of monitoring, we could show that we could heat this house close to Vienna with 90% surplus energy from a wind park. Not only wind, but wind that was somehow too much in the grid, making us a demand problem, a demand side problem. So this convinced us, and we went on. This was a very famous project. It was the first time 160 flats, 2/3 for social housing. And what we wanted to show is that the people living in this flat for hopefully the next 100 years, they will have cool summers without using fossil energy. What is the technique in behind? Once again, we have this building component activated ceilings. We are using a standard heat pump, smaller than normal, and we have these geothermal drillings. So 3 flats use 1 drilling. And this is summer in one of these flats. We rented one to show how this flat reacts on a heat wave, on a typical heat wave running through Europe, running through Vienna. And what you see is we simply pumping the water from the ground, from the deep grilling through the concrete ceiling, starting at May, in the middle of May, and ending this somewhere in September, we could keep the temperature in this social housing project in the city of Vienna seriously beyond 25 degrees. There was no second when one of these flats had more than 25 degrees, mostly between 23 and 24 degrees. What are the costs? The energy needed to pump the water through the ceiling and down in the deep drilling is 25 watts per flat. You know, I have an internet device, a WLAN modem in this flat. It uses 50 watts. If you put your, so for 25 watts, we are cooling these flats. And the good thing, the second good thing is we are regenerating the ground under the deep drilling, so we can start with a higher soil temperature when the next winter season is coming for heating. So it's even an advantage to heat the house in the next season. And obviously another example, and I'm very proud of this. This is an education campus in Vienna, Aspern. 20,000 square meters. Do you remember your school building? I think you do. Did it look that way? Mine, not. This is a school building with 48 classrooms, 20,000 square meters, and once again, deep drillings, heat pump, concrete core activation. And it is used all year round. And more than 90% of the energy to heat this building and to cool this building is coming on site via the deep drillings and having a photovoltaic solar panels on the roof. So 90% of the energy is collected under the base plate and on the roof. And once again, this cool building is also used in summer. And if you go there in summer, if it's 35 degrees outside, you go in there and it's like an oasis, very comfortable. And what we do there in a very simple way, in my eyes, has potential to be spread over the world. You all know, last year Austria was growing by 70,000 people. It has something to do with the Ukrainian war. And the years before, Vienna grew 250,000 people. So Austria is one of these areas that is growing. But not only Austria is growing, the world is growing. And we know we are getting 2 billion new people on the world in the next years, I would say. And they are not living in such beautiful buildings I just showed you. They are not living in the surrounding. They are mostly living in buildings like that. Here is mankind is living in buildings like that. How shall we decarbonize these buildings? And I'm pretty convinced that with storage capacity and with the potential to generate energy in the desert, outside, or offshore, or wherever, on roof. But to be honest, if you have 35 floors, you can only decarbonize the first 3 ones with the photovoltaic on the roof. The other 30 has then to come from somewhere. So I'm convinced that this technology of using houses as energy hubs can really make the way around the world. In Vienna, we have, in the last 3 years, we made somewhere around, it's an estimate of 1 million square meters. That's probably 10–15% of the housing area in Vienna. And in the moment, it's going up. And I would say Vienna is the hotspot for a storing thermal component activation. And yeah, that's what I wanted to explain to you. Thank you.
Yeah. Thank you for this case study. We are now moving, and I'm physically coming to you. We are moving closer to the policy. Zoltan, you will share with us sort of a low carbon building or construction roadmap, which then gets us more into the policy debate. Once you have done your presentation, we are discussing what kind of policies will be needed. So, please.
Thank you, Christian. Thank you, everyone. This is the moment when I wish to have like 3 hands. And it's true, what I wanted to talk about today is less of a case study or like a best practice example, but more like, more like a link towards the second session. And so basically, I just wanted to pick up one of the, I think Peter was mentioning that we have a goal, but we don't really have a plan. So I just wanted to share a couple of insights of technical study that we are preparing for the European Commission in preparation of a whole life carbon roadmap for the building sector, and just to understand what is basically as the baseline we are having today in terms of carbon emissions coming from the building sector, and where we have to be, and what are the steps that we will have to do all together, because I think that's probably one of the main messages that I want to get across, is that we are all in this together, and it's not just about building material decarbonization, but a lot more. It's also about demand reduction. But before that, very quickly, so I'm working for the Building Performance Institute of Europe. We are an independent think tank based in Brussels, very much in the Brussels bubble. And we have been traditionally working on the energy performance of the building, so very much limited to the use and operation phase of the building. But over the last 3 or 4 years, we have considerably expanded the scope of our work also to capture the wider environmental and social impacts of buildings and basically cover the entire life cycle. Now, Marcella was talking about the dynamics and actually the importance of why we have to look at the whole life cycle of emissions coming from the buildings, which has been in a way a blind spot currently of European and to a certain extent most of member states' building regulations and building codes as well. And the reason why we have to look to have a sort of life cycle perspective on building performance is because we see that as the operational efficiency standards are getting more and more ambitious, and actually they are delivering extremely useful and extremely relevant operational carbon savings. The problem is that this has a carbon cost. And actually the material-related embodied carbon that we are talking about in case of a high-performance energy, high energy performance building is increasing. So what you see here is building level, individual building level European averages. This is based on a collection of archetypes that we have built to represent the European building stock. And you see these are average values. But basically what you see that with standard energy efficiency building level, we have something around 34% of embodied carbon from the whole life cycle of the building. But in case of high energy performance buildings, we have really the majority of emissions are actually the ones which are embodied in materials. And that's not just the issue, but because there is also a very important time element to these emissions, because these are the emissions which are emitted today. And these are the emissions which cannot be mitigated, very much like through an energy efficiency renovation. You reduce operational energy demand, but the fact with upfront emissions is something that is happening now. And even before the building is being occupied or being handed over or being commissioned, these greenhouse gases are already like heating the atmosphere. So actually addressing these as a matter of urgency is very important. It makes a very effective climate mitigation action. So this was the individual building level, but once we are scaling up, we change completely our perspective and we look at what happens at the European building stock. And this was part of the work that we are currently doing for the European Commission together with KU Leuven and Ramboll, is to understand what happens if we keep current practices and we keep the existing policy landscape or legislation in place. And actually what you see that there is an increasing gap in terms of carbon savings, and we are not getting very close to what we need to be in terms of like a climate neutral building stock. You also see that some of these emission savings are actually from energy efficiency renovations. So these are from operational carbon savings. And in the lack of legislation targeting specifically embodied carbon or life cycle carbon at the building level, we are not doing much in terms of removing actually the embodied carbon parts of the building stock. And one of the reasons why we don't really have a policy framework for tackling, for addressing embodied carbon in buildings is because we lack the evidence base. So currently, we don't really have a very robust evidence base of exactly what is happening, where are the carbon hotspots, what is the magnitude of the emissions which are embodied in the material. So this work in a way is groundbreaking, is new in the sense of it provides the sufficient reassurance for policymakers to be able to move forwards with legislation on embodied carbon. So these are the carbon hotspots when we looked at the building materials. And I have to make clear right from the beginning that the intention here is not to pick certain materials as being good or bad. That's not the point. I think the point here is that they are all together and they are all together needed and they need to be part of collectively of a cumulative policy strategy to drive down the carbon performance of the building stock. The other is that certain material categories were like known carbon hotspots for the building sector. Others were a bit more surprising, like the likes of paint and glue. And again, these are this to a certain extent is because actually embodied carbon comes specifically from construction as well as renovation activities. And these are very little part of the actual building stock. We have a very low construction rate, something like 1.4%, and even lower renovation rate of 1%. So that's 2.4 to 2.5% of the building stock, which are actually responsible for this spike of emissions. The rest of the buildings are just going through maintenance and use and operation. So therefore you have other material categories like paints and glue, which was something like a bit of a surprise that they should be also part of this carbon reduction strategy. Right, but solutions exist to drive down carbon. And we have looked at, and I come back to Marcela's reference to the IPCC report, which actually categorized the carbon reduction solutions into avoid, shift, and improve categories. And this is the sort of taxonomy, this is the classification that we also analyzed and modeled in this study. And very importantly, these are indeed not just the improve and the shift measures, but very importantly, it's also about preventing and or reducing the need actually to have like new constructions or to have more construction materials than actually is needed to fulfill a very specific purpose or use. So these materials, they do exist. And importantly, we also applied a very comprehensive set of criteria to assess what is their potential to drive down carbon, because it's not just, as I said, it's not just about material decarbonization. It's also about driving down demand. It's also about making sure that you are using the right sort of materials in the right sort of places. What is the availability of locally sourced materials? What are the relevant materials that are applicable to certain construction types and building types and so on? So the picture is a bit more complex. But if we apply this, the key message is that we can bring down whole life carbon emissions from the buildings, and we can bring down, together with these technological solutions, but also with the demand measures, so with the sufficiency measures, we can drive them down something like 75%. And this with today available technologies. We haven't included those ones, technological breakthroughs that may, or even renovation-related embodied carbon reduction solutions, where simply we don't have yet enough research, we don't have yet enough data. Most of the embodied carbon research has been in new constructions, but with renovations, and we know we have a huge renovation challenge ahead of us. We simply haven't even touched this topic. So finally, the key takeaways. So it is possible to reduce life cycle emissions, and this is with solutions that are available today. But this will require a very comprehensive and almost like a transformative sort of approach to how we build, how we renovate, how we use currently our buildings. And there is also a very important, and I come back to the previous slide, there is also a very important sequence of actually how we are going to approach this. And this is, I think, an important message for policymakers as well, that you see that most of the carbon savings are in operational performance. So that means that the current focus of the legislation on energy efficiency renovation is right, is correct. We have to continue pursuing this. Then the next step is to drive down upfront emissions, so embodied carbon from new construction. So the proposal of the European Commission to focus on, in the Energy Performance of Buildings Directive, to focus on disclosures for new constructions, disclosures of whole life carbon, is very important, because that's indeed, in the current, in the next 10 or 20 years, is the most relevant embodied carbon hotspot. But after this, it's very important also to focus on renovations and to optimize renovations for whole life carbon performance. And then finally, I think we can do this simply because, looking just for inspiration, we have been using low carbon materials something like 50 or 60 years ago. So it is possible.
Thank you. Here we came to the end of our sort of case studies presentation. Katharina Knappen-Wirlich from DG Grow is now, what do you make out of this and how do you want to take this further? Lots of good opportunities. I guess there are a few trade-offs somewhere along the way, which you from the European Commission, DG Grow, and the others will have to deal with. So please, if you give your comments, and that will kick off the panel discussion, and then I would invite all the other panelists to join us. So Katharina, please.
Well, thank you very much. I will probably have to disappoint you if you expect from me now detailed comments on the presentations that have been made. Some of you know that I joined construction policy about half a year ago. What seemed at the beginning to be a lifetime now seems like a second. So I'm still learning a lot, which means that you cannot expect loads of learned comments on what you do. But what you could expect is that I listened carefully to everything you say. But you can also expect that most of my colleagues know much more about it and would have been less enthusiastic and oh wow, I learned something new than I have been the last 3/4 of an hour. But anyway, I think I was invited to kick off the discussion and somehow set the scene by talking a bit about our construction policy. And you're the ones who implement it. And by setting the scene, I like to start by saying that, well, we always have to be clear. Here, I mean, I'm speaking to friends, I'm speaking to professionals, that construction matters. It really matters, not only because of the 38% of carbon here and this and there, because it matters for us just as human beings. And not only for our survival, because it shapes how we live today. It also shapes how we work today and how we party. And then we come how, whether we and our children and grandchildren and great-grandchildren will still be able to live, work, and party. But we also look at what is now and how the construction ecosystem has developed in the last years. And certainly the recent years have been pretty challenging. COVID, Russia's invasion, price hike, material shortages, nothing new for you. But now the outlook for the industry as such is positive. Construction has weathered the storm, also not new to you. So that will allow us to look much more closer, and we should look much more closer at everything you have presented and at all solutions in this respect. While construction is still facing major challenges, the high fragmentation, the low productivity in general, some glimpses also in your presentation, I think, of the low productivity in general. The lack of digitalization. I mean, there are not many people who 3D print the roofs of garages. And there are even many people who think of 3D printing as such a niche thing. We don't need standards for it. We find that rather sad, but we haven't been able to convince the other stakeholders in European legislation. And we have the ambitions of the renovation wave. And at the same time, we need the green transition, the 33% of all waste in construction, the 40% of energy use in buildings, and the fact that 70% of buildings are inefficient. I'm often complaining about the fact that my first floor flat that's very deep is extremely dark during the day. My husband said that's wonderful for the furniture because it doesn't change color. I say, yeah, but it's not good for me. But in fact, it's probably energy-wise, it's quite good that it's dark and cold during the day, whatever the temperature outside. So now is the time also to seize the opportunities, the legal, regulatory ones, and the political ones. A few days ago, somewhere else, I asked, how many of you know about the transition pathway for construction? Who has read it? So it sounds like it is. I always think when I go, oh, everybody has read that. I totally overestimate our own reach. See, I'm the only one who isn't really the expert. No, well, for the transition pathway, I'm apparently slightly more of an expert than most of you. The transition pathway is our vision for construction 2030. We published in March 2023 this vision. Where do we see construction to go by 2030? And who could do what to make that happen? And at the same time, we have called for all actors in the construction ecosystem to make commitments, to propose actions, and to implement them that will make it happen. So it's not, the transition pathway is not a policy paper. The Commission will do 100 wonderful things, and you can be there, look at the 100 wonderful things, and, oh, they have done this that I haven't done very well, and this they haven't done at all. Because it's for all of us together and all the other stakeholders in the construction business. And that's also because it's for everybody, we did it with everybody. The high-level construction forum is our forum. It's big. It's not always only high level. So if you consider yourself not sufficiently high level, you are very heartily invited to take part. And if you are really high level, oh, I don't want the people who are not less high level, well, I think you have to accept them. We want to bring together all the actors who are interested in construction policy making, but also in construction activities, who actually do it on the ground. And everybody can join. There are webinars, there are discussion groups, and there has been the co-creation of the transition pathway. So it's actually worth reading. It is articulated around actually 6 pillars. I won't go into detail. I think I also have 7 minutes. I always complain about speakers who speak way too fast, and then I do the same thing. So I try to slow down. And still, there are 6 pillars. First, competitiveness. Well, if construction industry doesn't stay competitive, we have some difficulties. Skills and talent. This isn't the focus here, but in reality, it's important for all of you to attract the people and that are actually going to work in and for construction. And I think since I joined, that's the meeting in which the gender balance is best of all the meetings I've been to. And that doesn't say that much, correct? So we have to attract talent. We have to attract talent of all sides, well, of all gender, and all capacities and abilities. And we have to have an enabling legal framework. That's the 3rd pillar. We focus on research innovation, on finance, and closing the loop. We all live in buildings, to a safe and fair built environment. And from our side, what do we contribute now in practice to that? I would like to mention 2 points. First, we really try to pave the way for more sustainable buildings, and that project is part of it. And so is also, well, the report on the life cycle global warming potential and the levels framework. Because, and I don't know if anybody really clearly mentioned it, it's not at product level, it's at building level and along the whole life cycle that we really have to look at it. It underlies all your presentations, but it's worth repeating. And second, and I think I was supposed to say something about it, is the regulatory side. We want to support all the wonderful things you talked about by a regulatory framework that allows for it and that encourages it. So we have proposed a new construction product regulation. We are discussing it at the moment separately with Council and Parliament. How many of you live in the Brussels bubble? Or most, but not everybody. So the ones of the Brussels bubbles, you all know how our legislative processes work. The others possibly a bit less. We make our proposal, and then it's out of our hands. Then the member states look at it in council and say, oh, no, I don't really like that. I want to change this and this and this. At the same time, Parliament looks at it, even more complicated, because we have the member states and the political, and they also come up with an opinion on what we've done. And then we have three versions: our version, the council version, the Parliament version. And then comes the trading on what is actually the final version. At the moment, we are coming to the end of the council and the Parliament making up their position on our proposal. And the aim, the most important aims for this meeting here on our proposal was to have, to provide in the future the harmonized standards that allow to calculate in the end the life cycle emissions of buildings, so that there is one, for the time being, one obligatory criterion to declare the global warming potential of construction products. The idea is that it will provide the information you need in order to calculate. But it's also supposed to provide the information all through the supply chain of the product. We talked about concrete, we talked about cement. Well, if in the concrete producer does not have the data for the cement, or does not, then he can't really do that. That's why we thought everybody in the supply chain is an important economic operator. The council at the moment does not think so. At the same time, at the moment, we have the eco-design for sustainable products agreed pretty much. At the moment, the construction products regulation risks to fall behind the ambitions of the eco-design. We find that highly problematic, and we're still trying to influence the council members not to also find that highly problematic, because we do not believe that should be the case. We are also discussing, for you professionals a bit less important, the possibility to have a labeling like traffic light labeling. Well, the buzzword is traffic light labeling, but it could be something else than a traffic light. Could be a circle, could be all sorts of things, but an easily visible labeling for some of the products, for some of the standards. I still haven't really got behind, understood the idea why quite a few member states think that's not a good idea. Yes, construction products are mainly for a professional market and they don't need it. Yeah, but it doesn't harm to have the possibility to have it. And the idea is not that each of the most technical products has to also have a sort of easily readable labeling on the environmental performance. It gives the possibility to do that, especially where consumers actually buy construction products. These are the two main points where we are worried, and where we will see what happens. We will also see how far that may change in the negotiations. Our aim is to have a new construction product regulation before the Parliament stops working. And we cross our fingers that that's going to be the case. And I don't know whether that sets the scene for the panelists.
It does. It does. Thank you. If you don't mind, why don't you take the seat? And also the other panelists, Joanna and Rebecca and Zolt, if you just could sit here. And so, yeah, you know, there's a seat for everybody, I hope. You know, why don't you sit here in the middle? and I need to sit in front of the CEPS logo. You will understand. So thank you all. We had heard a lot of points. I would now like straight to go to the other two panelists. Rebecca, I mean, I have here, 15 questions. I don't want to derail them off. What do you take of this? We talked a lot about labeling. I think if I understood you correct, Katharina, you wouldn't mind if somebody has an opinion on whether labeling is a good thing or not. I think you're working on this, and maybe also here in the room. So Rebecca, when I hear about all this labeling or standards, we have seen one standard here proposed. Is that a good one? How do we bring this together? What is really a good standard? We have seen nine qualities, which sounds to me very much as a lot of trade-offs. You cannot have all at the same time at 100%. So how do we deal with this? Now, Rebecca, you don't need to answer all this, just your take on this. But before you start, if you have questions here in the room, comments, violent disagreement, just raise your hand and we will get you into the debate immediately.
Okay, so, well, Rebecca Lamas, maybe perhaps better to start what I'm doing on a daily basis. Very busy on embodied carbon for development. So I work for Goodman within an amazing team of sustainability practitioners. It's a challenge every day also on the private sector to really push forward for deploying those low carbon, and that's where standards play their role. For me, it's a bit tricky. It's been already a roller coaster of a day because I came through with an idea with what to talk about. Then I heard all the talks and I had another idea and now another question. So please allow me to just be all over the place a little bit. I will try my best to respond. I just wanted to set the scene where I'm sitting. I'm really sitting between the technical managers in continental Europe, developing on a daily basis, and the funds, the ones that pay for what we are constructing. So definitely on the competitiveness is the first point. So I would like to throw some points regarding embodied carbon, where we're standing and how much it costs. And then let's put circularity in the mix just for even more fun. I would like to just raise the point of the market is ready for life cycle analysis. We've been doing it for years in the voluntary part of it because of certification. BREEAM in Europe, really a UK certification we've been using. In Germany and Austria, DGNB. We see in America, LEED. LCA is part of the voluntary certification part. Just hotspots are taken into account, not the whole building, it is true. But well, it is something we've been playing with. Not very well, because quality of data was lacking. But now on the compliance, I really would like to reiterate on the importance of having life cycle analysis in the disclosure of development. And I also want to reiterate, let's not just account for phases A1 to A5, embodied carbon, of new builds, but I reiterate the point on retrofits, refurbishment, replacements, B4, B5, let's not forget about it. 15% of the standing buildings are G standard. EPC-wise in Europe, this is a lot of embodied carbon that will be displaced. I haven't responded yet on the standard, but I'm coming. Is it important? Standards are important, yes. But how fast do we want to go? So I agree with the point of Katharina of we need to be looking at building level first. Do we want to really push forward for the lowering the carbon? We know where we have to look at structural parts of the building, slab foundation, and off we go, really. Let's not reinvent the wheel. Standards will be very much needed. Yes, they are not needed today in terms of the whole set of products, but let's look at the hotspots. So I would focus on that scope hotspots. Also, standards really are important for bringing circularity in the mix. It was mentioned before, yeah, let's use gravels for the structural concrete more and more. And because I would like to focus on structural concrete, because non-structural, well, we've been proving a bunch of new things and very cool stuff are happening. Problem are structural parts of the building. And standards are set at national level concrete-wise, and well, they are really blocking the deployment of circularity. Why? Well, we see in Switzerland, we have projects standing, structural concrete, using 50% of recycled gravels. Why Germany and France are really stopping at 10 and 20% of recycled gravels? Those are the same buildings with same professionals as structural engineers. So standards overall are very important, and they're blocking. I could go on, but you gave me 3-4 minutes, so I'll stop here.
Thank you. Jana? You need a microphone, yeah.
Yeah, so of course, it's been interesting really to listen to all the developments presented. So I work for Kingspan, which is a company that makes construction materials for largely insulation materials, but also other products for the envelope of the buildings. We are looking at traditionally was energy efficiency of the product, but now it's more and more embodied carbon. So the decarbonization is important from regulation, but also from customer demand. And we try to look at it in different ways. What we need to look at is sort of bio-based raw materials is one thing, working with the suppliers on how they are decarbonizing their manufacturing process. That's very important. I think 85% of our carbon footprint comes from the raw material. So that's really important. Then we're looking at bio-based actual materials. So next generation insulation, which might be hemp, grass, or mycelium, which is a sort of mushroom product. Those are all interesting, but today, since we're talking policy, I wanted to maybe look at another part of the material efficiency that we are looking at with the reconstruct, which is how to use all that material which is already out there. So the huge amount of construction waste, which is the biggest volume of EU waste materials, and how to be able to actually make use of it. And what you say, Rebecca, about the standards, that's an important point. But what we're really kind of a little bit excited about is this extended producer responsibility scheme in France, which is starting this year, and which will function a little bit like what we have for like electronics. You take your vacuum cleaner back to the shop, and the recycling cost is included in the price. So you will have that in France for construction materials, and that's, of course, a really new and pioneering thing. Basically, all manufacturers in France put an extra contribution price onto their material, and that money is then built together, and it will build up this huge network of collection, sorting, and finding secondary uses. And that'll be, of course, a massive undertaking. But we are really optimistic in the sense that for us as a manufacturer, it can be difficult to kind of be in charge for the end of life use of your material, 60, 70 years later. So therefore, a collective system will work hopefully much better. And the way that it works is that this fee, which will today pay for the system, will be differentiated from next year based on how circular the material is. So it should encourage upfront, basically, because we pay more if our materials are less circular. But also it will bring all those materials together. So every 20 kilometers in France, there will be some kind of collection point. And then you'll have to find a secondary use, which will have to be sort of local and regional, because it can't be that you then drive 500 kilometers with some stuff. So that's also really interesting. And we're looking at it as in there's going to be secondary uses of our type of materials, which maybe we wouldn't be able to figure out, but somebody else is going to want to have that material. So I think that's something. I know that for the EU, this is sort of like where subsidiarity comes in play. Waste policy is more national, and buildings policy to many extent is national. But nevertheless, it's something which can be encouraged. Probably, I know the EU waste framework is being revised as well. So somehow this should contribute to the material efficiency, big picture.
Thank you. Can I go back to the small picture? Jana and also Rebecca, you heard all these examples. Is, going back to the view from the market, are these ideas that are put forward, are they taken up in the market, or are they staying pilots? Is there any incentives for, your clients to take them up? And and also maybe then later to Katharina and Solt, what would these incentives be? I mean, just let me also say, life cycle. I'm a great fan of life cycle, but I'm afraid that in 10 years we're still discussing life cycle because this is a very complicated matter. So something has to happen now to get these ideas or these pilots into the market.
Yeah, so then I'll go perhaps to the second pillar that was mentioned by Katerina, and it's the skills. So very much to go from those pilots to the real life, you need skilled structural engineers, and they are costly on a daily basis. So, and that cost is just not only on the upfront cost of the skill, is also extra time. And time means money in construction, as we all are involved in the sector. So what is happening is there is a delay on deploying those projects, and you have contracts, agreements with your tenants and occupants. They're expecting it to be ready in August 2023. But all of a sudden, you came across that you need 2 extra months and X amount of money up front for optimizing your structure, for example. So at least we are developers of data centers and logistics and offices. Those are big scale projects. I'm now with a big flagship for Europe. I'm trying my best to really use R0. So when you think about circular construction, and it's linked with Marcela's point on efficiency, and I always call it refusal. Don't use what you need, the R0 in circularity. The real case, it is quite difficult to take forward basically because of the upfront cost and extra time.
Yeah, so but that's for the commercial building, the large scale commercial building. There is a, Jonna, if you allow me, there is a question here and we will take that and then we come back to you.
Yes, thank you. It happens that I worked during 15 years in Saint-Gobain in purchasing, and especially I dedicated myself in the last years to recycling of cullet for glass wool, for flat glass, also replacing cement in the mortars by alternative like slag, fly ash, biomass ash, and so on. So I'm quite knowledgeable on the situation. The main thing for industrials is very difficult to shift from a virgin raw material to recycled material. The gap is huge. And for competitivity, the question is to having a virgin material at a good cost today, no problem. We pay and we increase the price when the price increase. So you see that the profitability of all the industries in construction this year has increased, last year also, because we pass over the cost to the end customer, okay? So the question is, what incentive should we give to the industry to take the risk to buy a recycled material where the recycling industry does not do the job because it's too complex? The only one who are knowledgeable, it's not you, it's the industry themselves, and they keep their property, their knowledge hidden, and they're not ready to open it. So it's not open source subject where it should be, because it's a problem that is for all industries, cement, glass wool, etc. They have all the same problems, but I tell you, they do not share. They do not share information, so they have to do it by themselves. And to pay back an investment in recycling when you do it yourself with the risk, the complexity, the source, the pit is not big enough for one industry. You should share with the competitors. They don't do it. So sorry, I'm a bit emotive because I tell you, I know a lot about this, and I see it's going far too slow.
Okay, thank you. We not only have a good gender balance, also a lot of emotional discussion in construction, which is, I think, good news. Jonna, there was this point, I think this was to all of you, this point, but Jonna, we still had this question, what do we do to get these projects, you know, with Marcella and others, bring them to the market?
Yeah, I think one has to work on so many different levels. So what we are doing to improve our own materials is really to work with all the suppliers. So we have a supplier forum with a third-party ESG measure for all of the suppliers, so that we really know that what they're saying about their product is the reality and what their objectives are. So that's to work for us to improve our products. But then it's true that the demand side, you know, for the better, the products with the better EPDs, the kind of data, there's a lot of demand in the Nordic countries, Germany to some extent, and you know, in France, but in a lot of other parts of Europe, there's not much demand. So of course, it sort of develops faster in some regions. And now we have the hope that in France, of course, there will be now a lot of drive for this recycled material. And then hopefully what you were saying, that there would be more collaboration, because in the collectives, they have to work together even to kind of set the circularity differentiation criteria, like where do you get a bonus, where do you get a malus for the pricing. And also to work together, the law sets it that the collectors have to have a 5-year circularity plan for all the materials of how they are going to improve. And that is a kind of collaboration. We will see how it works in practice, but one can be a bit optimistic maybe. I would say one thing on those is that the kind of focus, we at least think the focus for a single loop for materials is not going to be very practical. So when we make kind of, let's say, plastic insulation foam, which is a large part of our legacy materials, it's proven that to recycle, yes, you can do chemical recycling, but that will be a business case in some regions close to the manufacturing site or a chemical site, but in all the other areas it's some kind of mechanical recycling, and that's where other companies want to have the ground up foam to use mixed with concrete, maybe for flooring products. So these secondary loops, and that's in a way where the business case has to find the level where the waste material gets a value. Because if the waste material has no value, then how are you going to do this? It's going to have value.
So it needs targets, regulation. Zolt, you want to add on, and then Katharina, if you wish, to any of these points?
Yeah, I can also get emotional about policies, not so much about the technical details, but exactly on that point of like setting out clear targets, setting out the benchmarks. I think you wanted to talk about that, Rebecca, as well. You were saying that actually all this focus of building policies to have more life cycle perspective was actually market driven initially, and it was purely done on a voluntary basis, and a number of green building rating tools have paved the way and actually created awareness and demand for this. And actually they were very instrumental in showing the way that it's possible, how can this be done. For sure, starting at a higher level, maybe bigger construction development projects, but then it's also, it trickled down the moment when a couple of member states, mostly Nordics, France, the Netherlands, have embarked on extending the scope of their building regulations to regulate against life cycle emissions. And the example of Denmark, for instance, is quite interesting, because it's initially, after they have set out the disclosure and the measurement requirements, they also announced the future introduction of limit values. So basically putting a cap a target value on how much kilogram CO2 equivalent you can emit per square meter. And simply the announcement of this regulatory change has created quite a lot of demand and has created quite a lot of an upskilling and quite a lot of interest. So, and initially, the carbon limit values that were introduced were not punitive at all. Something like 95% of the new construction projects have actually complied very easily with the target. So there is a way of rolling this out incrementally without creating that sort of disruption on within the market and allowing for a gradual build-up of capacity, of skills, of SCA literacy, data quality, data availability, and the simplicity of using digital tools. I think in that sense, European policy is probably playing a bit of a catch-up. And it's very important that the policy files which have been, the revisions that are currently part of the political negotiations have really a long-term time horizon. So they are not only looking at 2030 like the EPPD currently has most of its whole life carbon provisions within a time horizon of 2030. It's very important to look beyond that and also just to make sure that there is, after the disclosure measures, there are also the introduction of whole life carbon limits and limit values are also on the table. And basically there is a methodology or there is a clear perspective of how these will be introduced, how these will be developed, the benchmark values, as well as how the building level targets are basically aligned with also the building, the sector level decarbonization pathways and allowable carbon budgets.
Thank you. Katharina, if you could hold for a second, there were 3 people to comment or ask questions, you know, please.
All right, thank you. Hi, everyone. I'm Berta. I work at CEPS 2 floors above. My question is about, my name is Berta Miget. I work at CEPS 2 floors above. I work mainly in trade, and my question is going to be about supply chains, because I'm wondering whether you in your day-to-day, when you're working with construction-related projects, actually bump into this issue. So, for example, you've been talking about raw materials, you've been talking about using different materials for construction. And I was wondering whether or not there's any pushback or any anxiety around how that can change supply chains both within the EU but also with third countries.
Thank you. Who was next? Yeah, 2 conveniently next to each other.
So I'm Joseph Kitzweger and I work for Holcim in Austria. Holcim is Lafarge in Austria and now we became Holcim as well. I just want to come back on this discussion like a chicken and egg. When nobody takes the final recycled material and if it is too expensive. I mean, in Austria, it started everything when depositing waste had been forbidden. I think this is the first step. So we don't need to start at the end, who takes the recycled material. I think we need to start on the other end. If you say, look, to take materials where still a lot of energy had been put in, if it is bricks, if it is plastics, if it is all the materials, there's a lot of energy inside. So why you should put it in a deposit, and I think the last deposit in Italy had been closed 5 years ago. So we were stupid enough to deposit and deposit. I think this is the starting point. And when you forbid depositing, I mean, in Austria in the 90s, removing a house was cheap because you remove it and put it to the deposit. Now you need to pay a lot, which pays the recycling company, and then the products are affordable and even economically possible for companies to take it. So we take in the cement plant 200,000 tons of bricks and we replace clay, for instance. So this kind of value chain, you know, what I wanted to add to this topic.
Okay, thank you for this comment. Yeah, no, okay. Let's go. There were 2, you know, concrete questions, and also Katharina still was sort of on the dock if you want to say something, please.
Well, thank you very much. I listened with great interest and I don't really know to what to limit what I want to say. It doesn't come in a very ordered way. Most of you use the word recycling. Don't forget, reuse before you recycle. Then extend the lifespan as much as possible before you actually reuse and recycle. And then what does recycling? Recycling means I make something else, correct? Out of what? Out of the waste. I may make the same thing again. But it's also about what do I actually then make? I, not so long ago, spoke to a window producer who told me, you know, we could make windows again, but the people who collect glass, they're perfectly happy to just melt it and make bottles out of it. But we could do not upcycling, but if not downcycling from the previous product is also an important issue to keep in mind to make it happen. Then I have to find my points. Then what can I use in buildings? And indeed, we at European level, we only provide the standards, which are by now definitely performance-based. They will not be recipe-based in the future. People mentioned that. And national building codes can define the performance they need. And they may overdo it. It's perfectly possible. Not our competence. So also to bring together actually the product regulation with the building regulation. And there you have all sorts of, you weigh, especially Nordics, they may request some specific performances, etc. We're very happy to do so. And we do not want to stifle innovation. One of the reasons that we passed to performance-based standards, not to lock in how we produce the materials today. And one word that hasn't been mentioned by anybody yet is the taxonomy. I'm not an expert on it, but my colleagues are working very, very intensely on it. And there will be building projects that will just not be taxonomy aligned. There won't be a possibility. And the idea is rather to guide investors like you to not invest in those that are not taxonomy aligned, and to make a stamp of honor out of taxonomy aligned project. And we really have worked very in great detail to find solutions. They are as good as all these taxonomies can be, but we try. And if you want to see the installation materials of the future, and if you pass near Schumann, come to our building in the next days. There is still an exhibition of the CBA joint undertaking that fosters bio-based solutions. And there is a mushroom insulation wall sample. So if you pass by, come into our lobby.
Thank you. If the others want to pick up some of these points, but I still also have a question to all of you. We got this point of regionalization. When it comes to regionalization, I always rings a bell, barriers to entry. You can really very closely say we only resource 50 kilometers. That means your competitors are within the 15 kilometers. To what extent don't we have a trade-off between this regionalization and full market opening? Do we need to restrict the market in order to get the carbon out of it? This was the question which I was raising. We don't need to go to this high-level question, but I just wanted to mention. Any of you want to pick up the points that have been made by anybody in the room?
I can get started. I'm happy to get started. Just so many questions, so many things. Indeed, I've forgotten a lot of things. Benchmarks, thank you. But I would like to perhaps focus really on solutions, because I could be here talking about issues and not proposing solutions, and I want to avoid that. So we've mentioned about, we haven't talked about, yes, we want more quality data. That's a lot of, much more data. I just see numbers coming in and out. You know, we're talking about different scopes. Am I accounting for the same scopes? Are all those life cycle analyses here in the presentation taking into account the same amount of years, the same amount of scopes? How are they accounting for square meters? So we're seeing beautiful numbers, but I had so many questions in my head. I was like, are we really comparing here apples to apples? We don't know, and we are working in the same sector. So I think, first of all, automatizing the whole chain will push definitely for the quality of data. Be sure we're all talking about the same. We've been using the same methods, yes, but accounting for scopes differently, even myself and my colleagues. So, I mean, it's just, it's easy. And how do we do that? We need to have information on buildings, on softwares. It must be a must. It's an old school sector. It was an old school sector. Let's be really in the new age of information. We need buildings information on softwares. A lot of general contractors in Europe have never used yes, building level software in their lives, and just yeah, oh wow. Anyway, automatization first, really building level information on softwares from day zero. Then point two, definitely disclosure, LCAs. They are in the EU taxonomy. You want to be EU taxonomy aligned, you have to disclose your carbon. Though I would love to be much more pushy. Why don't we benchmark, really? You have to be below 10% of what the market is offering. Just being very conservative. We have to push farther. Indeed, LCAs are in the disclosure. I believe we should be much more pushy. The circularity criteria is amazing, though. It's a hard one to match, I must say, on the taxonomy. That is a challenge for me for whenever it's actually fully published. Yes, benchmarks. And then perhaps on the supply chain changes and all these decisions, where are they bringing us? And just I would like to give one example on, we are SBTI committed, so we have to lower our carbon footprint in our embodied carbon as well as operations, but the market is just not ready to actually right now decrease 55% of my embodied carbon. So my investors are asking, okay, do it anyway. I need you to do it. So what do? We go for mass timber. And so you see a shift right now on the full actually procurement of materials. And I see it will be shifting quite a bit as well. That will put pressure on obviously steel and concrete, because obviously they will be still the winners on the game for structural, for infrastructure and structural parts of buildings as well. But I do see that my next projects to come will be mass timber.
Yeah, I think on the data and reporting and taxonomy, there is a lot of need for data, and you mentioned the quality of data. Sure, it will improve with time, but I think it's also quite complex. I mean, we as a company now, we're planning to, there is the corporate social responsibility reporting directive, taxonomy reporting, so we're needing to use Ernst & Young, and it's quite complex. EPDs as a structure to showcase for the products are quite expensive. And so it's good, of course, if there are some more simplified ways for smaller companies. I was going to ask our colleague Peter, I mean, how is it for SMEs to with all this showcasing and information and reporting? Because if it's complex for us as a big company and we have the opportunity to do it and we want to do it to show our products, but that's something for the regulator, of course, to think about how to be inclusive in this development.
Jonna, you don't need to answer this. Does the taxonomy help or hinder? Does the taxonomy help you or hinder?
It is an absolute requirement of our investors. So yes, we are reporting fully against it. I think what the complexity is that the rules, there's some interpretation, and you have to have a system where you explain this is how we've done the calculation, and that's where we need Ernst & Young. So I think when the reporting becomes more clear on how everybody's going to report, then it'll be more comparable. But I understand, of course, it takes some time, but we are looking at it as a positive thing. And I think even the CSRD is a positive thing. It's just that some reporting is not there's not a template out there to show how you know, human rights, how that impacts on your business model. So it gets complex. I think energy efficiency was easy. Now it's getting complicated.
Okay, thank you. Zolt, you're quickly, I just wanted to check with Marcella, Peter, and Sebastian whether you have short comments at that point. Yes, you tell me.
Thank you. I'll keep it very short, but just to add my 2 cents about it from a more academic perception. I'm not part of the Brussels bubble, but I am in the academic bubble, as we were discussing before. And sometimes we're confronted with frustration with the lack of knowledge. But to me, it's really good to hear the perspective of those who control funds or those who talk to those who control funds and companies and see that you're all very much aware of what's happening. I don't know if it's because you're in the Brussels bubble, but I'm happy to hear it, you know, and to get that feedback back. I'll just make one comment about skills that was presented by Katarina and discussed by you, Rebecca. It is a conceptually complex knowledge. I'm coming from LCA, so in terms of LCA specifically, it's very conceptually complex. So comparability, how you account for a thing, understanding how we model everything, it is complex. And teaching that and making sure this knowledge is built, the capacity is built, can be expensive. So from the academic side, we are really trying to push forward the notion that this type of knowledge should start in a bachelor level as mandatory education, you know, to, in my case, design decision makers, so engineers and architects, but it should be everywhere because right now regulations, standards, baseline, benchmarks, that's how we tackle the problem today. But I think we also have to, it's a multi-scale thing. We have to train young decision makers into making this knowledge innate, inherent, you know, preserving our environments. I'm a bit romantic in the sense, but preserving our environment should be part of who we are. So we're trying to push that forward as well. Thank you.
Thank you. Peter, you know, Sebastian? Yeah.
One word. Well, I'm in this LCA now since material flow analysis since 30 years. But once I decided to go for innovation and not too much for more and more details in LCA, because I realized we have to come out of the library. We have to really start innovating and show examples, not just data. My sector, my cement industry in Austria, we are now doing EPDs for all the cements of all the countries. And what happens now? So we are the first sector who makes 100% EPDs. The EPDs authorities are completely, they don't know how to do that. They have not enough people, not enough verifier. So it will take us, I think, I suppose, don't be angry with me, 1 year to get it on the ground, but we made a calculator, we made everything. In Germany, I heard I have to wait for 2 years. It's only the cement industry. Can you imagine if chemical industry would start to say, to turn the lever and say, let's make EPDs tomorrow for 100,000 products, then we're in a complete mess. Sorry to say that. We're in a complete mess. So, and it goes on with taxonomy. What I learned is, if a guy from the concrete or mineral business starts to be interesting to make innovation cross-border, to show that we can higher the share of renewable energy for heating and cooling by a factor of 5 with this simple technology, the first 10 years I had to explain why I am a cement guy, want to innovate in the plumber sector, in an energy sector. I shall build the house with bricks and stone and wood, and that's a complete other business that ruins my house afterwards and make all the pipes in it and you know, so the tradition, the long tradition, the 1,000-year tradition and the segmented market in the building and energy sector is one of the biggest problems to bring the carbon footprint of these buildings down. So how can the Commission really motivate cross-sectoral innovation? And sorry, all the LCA is just a tool. It doesn't really help us to really transform. I think here are the experts. We all know what to do. And this is important, innovation and cross-sectoral innovation.
Thank you. You raised the level of complexity one notch, but I think it's important. I don't know, Zolt, you wanted to pick up a few points. We are getting closer to the end. I promised you all to finish at 3 o'clock sharp, unless you have a really innovative idea towards the end. But Zolt, and then we have a last round before we.
Sebastian made a really great point about the what we have been discussing today, this afternoon. Generally, having a life cycle perspective on buildings really just brings out how much interconnected these sectors are, and basically the boundaries of what typically has been considered as building sector is actually cutting across a lot of other sectors. You've been talking about like bio-based and mushrooms, and so it's even pushing like agriculture or land use clearly. So it's very important also then the sort of policy responses, and not just market innovation, but policy responses also to just be more aligned and more cross-cutting in a way, just to make sure that we are not looking at it in silos. That is currently, unfortunately, still very much the case of the policy landscape affecting buildings, and basically bringing together more like product level policies with building level policies, what Katarina was articulating very persuasively this afternoon. So I think the beauty of having a life cycle approach to buildings, and just looking upstream and downstream of the impacts that we as policymakers, but also as market participants create, it really forces us to have to just think a bit more about ahead and before us, and then also it's just like prompting a bit more, maybe data sharing and collaboration as well.
Yeah, so thank you. Any other points you wanted to raise on, or of some of the comments? Then, no, Katharina, no final words. The Commission usually has the last word. I am the host. Okay, so I'm sure. Yeah, Rebecca.
Well, as I have Katarina here, and I can ask for more benchmarks, because we focus very often on low carbon, and we all know how to do LCAs. The method is ready. We're missing the same accounting at building level for circularity, because, well, you see the great majority is using now Building Circularity Index, but a lot of people are still wondering, should I use this one or which other one? And really looking at the the modularity of the building level as well, looking at circularity as a whole, and pushing for reuse, pushing for disassembly, and etc., should also be a focus, not only low carbon on the disclosure part as well.
Yeah, sure.
I can make points on to bring back the taxonomy discussion, because I think this is exactly where the principles like the reuse and reduce should be more sort of better represented in the taxonomy, which is, just by purpose, it's something to reward the best in class and just show things ahead, right? To show the additionality. Today, you are still able to demolish a building and build something new and comply with a very high performance requirement. So therefore, you are taxonomy compliant. But it's not something that we want to encourage, but more like reuse, repurpose what we have, just basically use our existing stock as much as possible.
Okay, a lot of nodding. That usually means we are coming really to the end. Now, let me just, look a bit back. We started off with fascinating new materials, and then within an instant, we were in the recycling, circularity, reuse, avoidance debate, which is partly Marcella, partly the reason this is the Brussels bubble. Circularity is now very high up. I mean, it is important for the overall climate debate. Then, of course, this doesn't make it easier, and we got back, and that I think was a very useful contribution also by the people, the people from the business make it clear it's not easier if the concept gets more complicated, but such is life. I think I took also away that innovation, there is innovative products, many of them, and now they should be brought to the market. So what can we do now to create demand for those? We scratched a little bit on the surface. It's complicated. It's clear you're moving from one set of established infrastructure to a whole new set of materials, which in construction takes time. Construction sectors is inert, rightly so, I believe. You don't want to have innovative buildings every second year, so that will take time. Then, yes, in the end of the day, it's probably going down this cross-sectoral. I mean, Stefan started to mention this with the proposal that cross-sectoral, approaches, which again makes things a little bit more complicated. But I think overall we have really come down to a couple of good ideas, lots of good examples of what can be done, and now it's up to the policy and also national regulators to make this happen. We'll certainly continue the debate also in Vienna, and we'll see what happens there. Now, let me finally say, I think this house urgently needs thermal component activation. Sebastian, I don't know whether it's still possibly retroactively. Let me thank you all for joining this discussion. It was, for Brussels purposes, quite a long afternoon. So thank you for spending that much time with us. And we'll be back at some stage probably with a solution. So let's give all the speakers and the presenters a big hand. Thank you. Okay, meeting adjourned. Yeah, good.